The X-ray. The term synonymous with broken bones is the most common form of diagnostic imaging in use today. Philips Medical Systems has been manufacturing X-ray equipment since 1919, and to date has over 50,000 machines in use around the globe. So how is an X-ray actually produced? There are two fundamental components to every X-ray system, a tube and a generator. When the generator applies a high voltage to the tube, it emits electrons. Inside the tube, these electrons hit an anode, a thick piece of spinning tungsten that weighs up to 4 pounds. This in turn releases the X-rays we need to create the image. By adjusting the voltage the generator applies to the tube, we can adjust the amount of electrons that are produced, which proportionately controls the amount of radiation that is generated. Procedures like mammographies require very little radiation, while others, like imaging a pelvis, require much more. Here we have a fairly typical X-ray system and a patient with a suspected broken bone. Our technician starts by placing either a film or digital receptor into this tray, commonly known as the bucky. Next, he adjusts the position of the tube, ensuring that not only is the right part being X-rayed, but that the standard 40-inch distance from tube to receptor is maintained. Lastly, lead shutters are adjusted to control the width of the X-ray beam. The light you see here is used to show the operator the area that will be exposed to radiation. Most modern machines, such as this Philips Bucky Diagnost, have automatic functionality which controls both the amount of radiation and exposure time required, although this can be manually adjusted by the operator as needed. The operator, now safely out of the room, can take the image. Once activated, it takes just a few hundredths of a second for the image to be taken, with the computer having controlled the power of the tube, measured the exposure level, and helped cool the tungsten anode. With the X-rays now off, the receptor can be safely removed for processing. The type of plate or receptor we used here is referred to as CR, or computed radiography. It has replaced traditional film as the most common type of receptor in use today. Inside this plastic cassette is the actual plate, which stores the image. The latest technology, which is starting to replace CR, is DR, or digital radiography. With DR, there is no plate to process and no cassette to eventually fail. The receptor stores the actual image as it's being taken, which can then be uploaded to a computer. Digital radiography has a resolution 10 times that of CR, which is 50 times better than traditional film methods. Having removed the receptor from the bucky, our technician now has to process the image so the doctors can make their diagnosis. After scanning the barcode on the outside of the casing to register the plate with the system, the cassette is placed into the Philips Aliva S+, a fully automatic device that opens the cassette, removes the plate, scans it, erases it, and returns it back into the cassette for future use. After just a few seconds, the image appears on the screen. From here it can be printed, stored, or sent to another computer anywhere in the world. This unit, the Philips Practix Convenio, is a portable version of the machine we just saw and is typically used with bedridden patients to check for the onset of pneumonia. Completely battery-operated, the cart has power-assisted wheels to help the operator move the unit from room to room. The machines we just saw are most commonly used in doctors' offices and outpatient centers, but the size of the machine and its relatively low resolution make it unsuitable for detailed work like barium studies. For that, Philips has two different devices, the Easy Diagnost Aliva and the Multi-Diagnost Aliva. The Easy Diagnost Aliva is equipped with an image intensifier and can have DR receptors in the table and wall stand. With the Multi-Diagnost Aliva, the customer can choose between an image intensifier or DR receptor, and this system is designed to produce 3D anatomical images. The Easy Diagnost Aliva is specially designed for use with barium studies, and the bed can be adjusted or completely inverted to perform both oral and enema-type examinations, as well as myelograms, which are specifically designed to detect problems around the spinal cord. As you can see, X-ray machines are used for much more than just broken bones. From the simple portable bedside devices right up to our $1.4 million Easy Diagnosta Leva, Philips is leading the market in X-ray imaging systems.